This is a nice typical example of the double integral. And as always, this is your surface floating in a space, and R should be defined by this information, that X is running from 0 to 1 and Y is running from 0 to 4. Integral from 0 to 1, integral from 0 to 4. The moment I decide 0 to 1 to be outside, the X should be outside. Since all are numbers, doesn't matter, but you have to be consistent with limits of integrations though. dy will be inside because 0 and 4 is inside. And then the function z, or whatever you call it, is 3x squared y cubed minus 5x to the 4. Now you better think which way you want to integrate first. Since you have all the numbers of the limits of integration, you can actually make a choice here. Seems like doesn't really matter, to be honest. But x, yeah, let's start with x, or y is also fine. Doesn't really matter, to be honest. It's same, easy, I would say. Let's start with y. Integral from 0 to 1 is weighting, dx is weighting, integrating with respect to y. There's only one y here. It's going to be 3x squared y to the 4 over 4. It looks ugly. Y to the 4 over 4 minus 5x to the 4 times y, because x is a constant. A bar from 0 to 4. Do you know what to plug? 0 and 4 should be plugged into y. You don't have to write it down, but make sure you don't mess up when you plug. Especially if you have 5 variables, you should keep in mind which one you are substituting in right now. Integral from 0 to 1. Plugging everywhere 4 is going to be, so let's simplify. It's fine actually, 3x squared 4 to the 4 over 4, which will be 4 cubed, minus 5x to the 4 times 4, so it's 20. Minus 0 and 0, so we can skip that, dx. Keep integrating with respect to x, 4. So this piece is 4 cubed. Let's simplify that. It will be 3 times 4 cubed. X, I want black color. Give me black. Okay, thank you. X cubed over 3, and that's why I'm not in a hurry to simplify the numbers, because more numbers showing up, so they will simplify later. X third over 3 minus 5 times 4. Let's not simplify that either. 5 times 4, why? Because it's going to be x to the 5 over 5. So we'll cancel out anyways. All this is inside of the definite integral from 0 to 1. Zeros will make everything 0, so our job is just to carefully plug 1 everywhere. 4 cubed times 1 minus 4. 4 cubed minus 4 gives you 60. That is a very nice looking number. So hopefully that was the most nice example actually from all the list. I liked it a lot. So keep practicing in double integration, and I think you're getting better. I have a very good feeling about this.